Art students and Pulley
on looking at pulley systems in regards to mechanical advantage, velocity ratios and efficiency. So what we have in front of us is a very simple fixed pulley system that you may have seen before. The big thing is that the pulley is fixed in a anchored spot. You'll also see that the effort and the load are exactly the same. I did that back to front. The load and the effort are exactly the same if this was 100% efficient. The distance which I would move for the load is going to be equal to the distance that I move by the effort. So you could actually say that the velocity ratio for this is 1, because it's equal distances. Okay, let's move on to a movable pulley system. In this scenario, the pulley can move up and down. We have a fixed point up the top, you can see here. And what you will notice is that we have the load and the effort is split into 2. Also, another thing that you would see about this, if I moved the distance 100 millimeters of the load, the effort would be doubled. It would be 200 millimeters. So there's a trade-off with distance. So what we could say here is the velocity ratio is 2 because I'm moving the effort twice the distance than the load distance. Now you will notice that we have, according to this fixed movable pulley, we have 2 ropes attached to it. And the velocity ratio is also 2. So movable pulley, 2 ropes, velocity ratio 2. There might be a link there. Okay, if we move on a little bit further, I can determine what the velocity ratio is by how many ropes are going to be attached to my movable pulley, which is attached to my load. So in this scenario, what I've got is the load, a fixed movable pulley, and I've got 2 ropes. So what I can say is that my velocity ratio, 2 ropes attached to the movable pulley, is 2. Wonderful. What do we have in the next one? Well, I'm glad you asked. We have a movable pulley attached to the load, and we have, we have 1, 2, 3, 4 ropes attached to the movable pulley. Velocity ratio, I can get this right, velocity ratio equals 4. Let's have a look at the next one. So we have this movable pulley, it's 2 pulleys attached together, attached to the load. So it's exactly the same as this one over here. So we can count up those ropes that are attached to the movable pulley system. And they are 1, 2, 3, 4. Wonderful. So what I can actually say is that my velocity ratio in this situation is 4. Excellent work. Let's keep moving on. We've got a couple of other complicated pulley systems that you see here. This one is we have 1, 2, 3, 4, 5 movable pulleys. Once you count up all the ropes attached to those movable pulleys, the velocity ratio is 9. So it's all got to do with the movable pulleys and, you know, counting those up. Here's some examples of real life where pulleys are used. This is called a block and tackle system, which they use to move a whole variety of things, including internal combustion engines out of trucks and cars, and yeah, a whole bunch of stuff. Here's some other examples here of movable pulley systems as well. Okay, so for now you move over to the flipped lesson until this, we can actually see this in a little bit more detailed of the amount of distance that things are moving according to the load, which is here, and the effort, which is just here, effort just here. So you can see in this scenario, the velocity ratio is going to be 1, boom, because the distance moved is the same. Then what we have here is the distance moved by the effort and the distance moved by the load is double. We've got 2 ropes, so the velocity ratio is 2. We can have a look here that the distance moved by the load compared to the effort. So that's 3 times the amount. Let's count up the amount of 1, 2, 3 ropes attached to the movable pulley. 3 velocity ratio, 3. Let's move to the next one. We've got 4. I shouldn't have circled that too quickly. We've got the distance moved by the load and the distance moved by the effort. That's 4 times the amount. Let's count the amount of ropes attached to this system. 1, 2, 3, 4. So the velocity ratio is 4. Wonderful. I think you get it. All right, let's just do a couple of, well, simple questions here. I've got a pulley system that shows an efficiency of 85%. Calculate the effort required to lift a load of 50 kilograms. So if I count these 1, 2, 3, I've got a velocity ratio of 3. So I just want to tell you before we get in, this is wrong. This is calculated to a velocity ratio of 2. So someone's got confused, not me. Okay, so let's have a look at this. First thing that we can say is efficiency equals mechanical advantage over velocity ratio. So we can say that mechanical advantage equals velocity ratio times efficiency. So I've got a velocity ratio of 3 in this scenario, then 3 times efficiency with 0.85. So let me grab my calculator really quickly. And that ends up being a 2.55 mechanical advantage. Now, mechanical advantage equals load over effort. So effort equals load divided by mechanical advantage. So if my load is 50, we need to times that by 9.8 to create a weight out of it. We divide that by 2.55, back to the trusty calculator. So that means that the effort required to lift this load is 192.16 newtons. So yeah, definitely wrong there. All right, so we've got another little one here. So let's work out what's the velocity ratio. So 1, 2, 3 attached to this movable pulley. So 1, 2, 3, that is the movable pulley. So the velocity ratio in this scenario is 3. Wonderful. Okay, so pulley system shows efficiency of 95%. Calculate the mass to be lifted with an effort of 260. All right, so same as before, efficiency equals mechanical advantage over velocity ratio. Wonderful. Therefore, the mechanical advantage equals efficiency. Well, we did it the other way around, didn't we? Velocity ratio times efficiency. It's not really going to matter. 3 times 0.95. Let me just go to the trusty calculator to work that out. 3 times 0.95. And the mechanical advantage equals 2.85. So therefore, mechanical advantage, we worked out before, mechanical advantage equals load over effort. Now, the load is going to equal mechanical advantage times the effort. Wonderful. So 2.85 was the mechanical advantage times the effort, which is 260. Okay, so let's times that by 260 and we get 741 newtons. Okay, so we've also got weight equals mass times gravity. So mass, because we're actually looking at the mass of this, that's what we want, equals the weight divided by gravity. So 741 divided by 9.8. Let's do that, divided by 9.8. And we equal 75.61 kilograms. All right, so yeah, that's correct according to this. Okay, so this is the end of the video, and what I'll get you to do is just go back into the theory part, just continue on with the questions. And you know, when I said that I got this wrong the first time because I only counted 2 instead of 3. So look, it happens to the best of us. This one's wrong, but all the other worked solutions should be right. But just move on and just complete as many of those as you can to help prepare you for the exam. Okay, that's the end of the video.
Add strings and should we go now?
You can use the